what I'm going to talk about today, it builds off some research that was done. It began last spring when I was teaching at the architectural design studio, a thesis project focusing on, let's say, regeneration or reinterpretation of a ship graveyard in Bangladesh, and the idea was to integrate neural language models. I believe it was one of the first studios probably which was trying to integrate this kind of methodology, since Midjourney was not yet released, and both DALL-E, VQGAN, Dream, and a lot of other platforms were still being developed and improved. And so what I'm going to talk about today is the work that built off of that, or let's say more or less some kind of intuitions and observations and questions that were raised from that kind of work. So the title of the presentation is Fragmented Layers of Design Thinking, targeting this kind of two-dimensional, let's say, limitation that AI models and specifically neural language models demonstrate, but at large, this is a characteristic of computer vision that I'd like to discuss. But particularly, I'm going to talk about limitations and opportunities of neural language model-assisted processes for design creativity. Again, accepting this kind of potential of any kind of AI workflow to increase the way we search for novel design solutions. Neural language models, as you may know, are artificial neural networks which use natural language processing and rely on the CLIP classification network, a zero-shot artificial neural network which has been trained on 400 million pairs of text to image. CLIP works by encoding a text prompt and searching for the correlation between the text image output until a perfect match between image and text is identified. Unlike a typical GAN, a generative adversarial network, for example, a cycle GAN or style GAN, CLIP has been trained on a non-domain specific data set. This diagram shows broadly, let's say, some milestones along the second half of the 20th century and the evolution of AI, building off from, of course, cybernetics and leading up to the biological kind of inspired artificial intelligence or connectionism in the 70s and 80s, to go through some winters only to reemerge about 10, 15 years ago with the notion of deep learning, and very recently the integration and advances in both computer vision and natural language processing. So my interest is to really examine both let's say the combination of models which exceed neural language, so GANs and neural language models, which has been discussed in a different paper that was presented this past spring, together with two colleagues of mine, but also to, in this case, focus on the limitations and some opportunities that current NLMs, neural language models, present. So the main premise, let's say, I would like to begin by talking about this notion of conceptual space and the opportunity to expand beyond the known search space that designers engage in. Professor Alexander Luria conducted an extensive survey in rural parts of the former USSR during the 1930s to document cognitive developmental differences between different social groups with little or no formal education. The experiments examined, among other things, the capacity for deduction and inference based on syllogisms and the capacity to imagine through the help of free questioning. His findings indicated a clear reliance of the subjects on their immediate practical experience for any sort of deduction and formulation of hypothetical situations which can lead to questioning. The results demonstrated that social organization and education facilitate the removal of cognition from the realm of the concrete to one where hypothetical syllogistic thinking can take place. This work thereby highlighted the difference between reconstructive imagination, which allows mental processing based on prior experience through memory, and the more complex creative imagination, which depends on abstract reasoning. In spite of advancements in psychology theories since Luria's findings and the change in associated terms, fundamentally, this distinction still makes sense. Both types of Luria's imagination are necessary for creative thinking to occur. A design workflow which aims to integrate neural language models must use the latter, creative imagination, to hypothesize potential promise of conceptual spaces which are often foreign to the problem, and the former, the reconstructive imagination, to draw on one's experience and learning to test and verify this. So taking advantage of the long-established capacity of artificial neural networks for interpolation, an attempt is made to bring into a project's ideation phase heterogeneous conceptual references to expand the solution search space. This is based on the assumption that analogical reasoning is held to be central in understanding creativity, since creative ideas occur via the establishment of novel conceptual associations between previously unconnected or only weakly accepted concepts. Acknowledging both the limiting and empowering capacity of language, the adoption of creative practices requires spanning long distances in the semantic space. To quote Kenneth, the role of semantic distance in creativity is intuitively embedded in the theory of creativity through the notion that the farther one moves from a concept in a semantic space, the more novel or creative the new concept will be. This is indeed reflected by the use of semantic distance as a proxy for creativity in recent studies on creativity neurocognition. The notion of exploring semantic space is also grounded on the theory of creativity, which accepts combinational creativity as the most common form, according to Margaret Bowden. Neural language models offer a workflow which allows designers to access various conceptual spaces by pooling references from different non-architectural domains as dictated by the project context. And this is what you can see in this diagram, where different kind of thematic areas were merged with architecture and shipbreaking, which was, let's say, the backbone of the project, on which this research is fundamentally based. So this diagram shows the intentionality to, let's say, nest a series of different language models, neural language models like Wombo Dream, VideoGAN and Clip, Midjourney, and more recently DALL-E 2, the improved version of DALL-E 2. So more than 2,600 images were generated using a number of clip-guided NLMs. Wombo Dream and VideoGAN Clip are relying on GAN-based generation, so relying on generative adversarial networks for the generation of the images, while Midjourney and DALL-E 2, while they're still using the clip as a classifier, they are guided by diffusion-based generator models. The structure and outcomes of different kind of neural language models experiments are going to be briefly discussed, with an objective to identify ways to increase our agency by intervening in the process of the AI model. In some cases, this involves either recycling the output back to the NLM at the same or different resolution, or curating the reference images to imagine parts which are not there, while guiding the model with image references locally. Some models, particularly Wombo Dream and Midjourney, seem to work better for developing unexpected scenarios which are not anticipated, while others like DALL-E 2 seem more straightforward. The capacity for realism can be good for visualizing an idea, but not so much in exploring it further. Certain possible bias in the algorithm that pushes less speculative, grainy results is not necessarily attractive for a heuristic approach like design ideation. Other neural language models allow more control over input and output and are therefore considered good mediators. We can see here some of the examples from the, let's say, a kind of collection from results from the first neural language model, the Wombo Dream, leading to a series of results which elaborate and refine the same family of text prompts in VideoGAN and Clip to lead to a third family of visual outcomes in Midjourney, all within the thematic umbrella of the slum, either like a sheep slum or a tree slum in this case. We can see a very brief comparison of particular images which are generated based on a very same or at least very similar prompts in 4 of the different clip-guided NLMs. And specifically, a couple of things I wanted to talk about are feature enhancement and imagining of features which are not there. And in this case, you can see that the particular outcomes which are generated based on a text prompt in an early language model back in early spring when the Wombo Dream, I think, had recently been released, feeding into VideoGAN plus Clip in order to recreate the same prompt with a unique characteristic of the second network, and then running this at a different resolution, running it at a lower resolution to, let's say, structure a particular low-level feature compositional structure, which is then retained by feeding in the same prompt into VQGAN and CLIP and running it at a higher resolution at 512 by 512, only to be able to generate a new set of high-level features, meaning a series of details at the more refined level. This is all done with a series of both initial and target images and alternating between this kind of cyclical loop between input and output across the neural language models. Here you can see some of the results by trying to kind of refine a certain prompt, running it through VQGAN and CLIP at a lower resolution in order to design a particular low-level composition, and then discover new high-level features within that composition at a 512 resolution, so which you can see here at the bottom. Here we can also see that several image features are enhanced by using outputs as input reference images among different kind of generations of VQGAN and CLIP runs. In this case, running 1,000 iterations starting from noise, and then running again the 1,000th iteration of that first trial through another 1,000 iterations in order to refine the high-level features while preserving the low-level compositional structure of the image. We've also looked at color manipulation by combining different ways initial and target image references, right? And in this case, we can see that using a color gradient as well as an additional result from a prior neural language model, we can achieve a certain guidance of the, let's say, a color gradient in addition to discovering new high-level features for those kind of results. With regards to stitching, primarily we looked at three different methods. One is relying on fairly old content-aware filter, which has some embedded AI tools within Photoshop in order to stitch together a series of results from VQGAN and CLIP, and then only trying to recreate locally some of those features by plugging the original VQGAN and CLIP results back into the same neural language models, albeit this time removing certain parts of the image and allowing the network to discover. This, in some cases, required going much higher in the number of iterations, ranging up to from, instead of 1,000 iterations, going up to 6,500 in this case, or maybe even up to 20,000 iterations. And with the advent of DALL-E 2 and the new outpainting feature, of course, it's quite interesting to see that we can extrapolate particular qualities from a certain set of results from, let's say, Wombo Dream or VQGAN plus CLIP, and in this case, Midjourney, and run it through DALL-E in order to expand the canvas by virtue of plugging in the same prompt in an incremental manner. So what you can see here is 4 original outcomes where DALL-E 2 is used, the outpainting feature is used to create, to just fill a whole canvas of 1024 by 2024 pixels, whereas the image to the right, the larger image, is a compound, let's say, composite hybrid from 5 different kind of passes, focusing on that central image. I'm not sure how I'm doing with time, so I'm just going to skip maybe to a couple of important observations relative to the work, particularly with regards to the 2-dimensional to 3-dimensional translation. As everybody is aware, in spite of the remarkable speed and mostly interpolative abilities, the computer vision models, like in this case NLMs, but also generative adversarial networks in other kind of work, are incomplete towards autonomously providing a complete vision of a spatial scenario, because their 2-dimensional output can be seen only as a kind of a fragment, let's say, of a complete design picture. Therefore, extensive processing is necessary to interpret this information into some kind of 3-dimensional format. Using displacement mapping, one can translate the two-dimensional qualities of an image to a 3D mesh for evaluation and further manipulation. Although both the stitching techniques mentioned earlier and the displacement mapping seem constraining, they in fact present a silver lining when it comes to furthering design creativity, because they not only encourage, but actually force designers to scrutinize our methods from a cognitive standpoint during an interrogation of the design intentionality. The designer is therefore invited to reconsider the topological truth of the two-dimensional outcomes during displacement, so this method becomes important not only as a process, but as a rationale of decision-making. The necessity to consider the extension of these two-dimensional visual scenarios into spatial opportunities echoes some older comments also by Neil Spiller on the creative latency of drawing. Similar to the drawing, these two-dimensional outputs demonstrate an ability to hold, to quote Spiller, an imagined past and an imagined future, thereby warranting a thorough engagement in the creative act of designing. A couple of important observations in terms of understanding the limitation, particularly of neural language models, is their inability to work in a multimodal manner. One challenge with NLMs, as identified by Bolojan, Vermisso, and Yusif, is that they cannot encapsulate and encode design complexity in a multimodal way, leading to a reductionist interpretation of certain design intentions. In spite of NLM's capacity to complement text information with other semantic data, like image references, we cannot consider this process as multimodal. Rather than exploiting a neural language model's heuristic potential, adding an image reference to assist the text prompt may result in a biased search, which excludes certain areas of the network's latent space that would have been otherwise accessible. Bypassing this problem may require entering a deeply nested categorical representation that is extensively analytical. This presupposes examining the degree of reliance on archetypical representation of a concept over representations which use detailed examples and can be both empowering and limiting. The role of categorical archetypes is to provide simple comparative platforms for the assimilation of new concepts. An archetype can be described as the mother of all examples, and therefore semantic descriptors for a given concept. An architectural example may include, for instance, the category of a cathedral structure. A more specific manifestation of this category can be described as a cathedral building by a given architect, in this case, perhaps Gaudí, while an even more determined selection can point to work belonging to the previous category, like the Cathedral of Sagrada Familia. As we move away from the archetype, though, it may naturally seem more possible to semantically capture the nuanced qualities of a given architecture because we are increasing the amount of descriptors. However, we need to be careful of certain intermediate states, which, although seem less archetypical, rely on symbolic means and might potentially collapse a great deal of the details they encapsulate. Naming the architect in this case invokes an iconographic relationship with his work that automatically constrains the neural language model search beyond the localized latent space. Therefore, by moving away from an archetype, we enable the neural language model to search in a more multimodal fashion, as it can access a larger potential repertoire relative to the architect in question. I think this is my penultimate slide, and particularly relative to that discussion around archetypes and the notion of conceptual distance. We can see that if we begin to remaster 4 original upscaled options, which have been generated in Midjourney, and we can see to the left here an original option, and then to the right the remastered versions. It becomes clear that sometimes the remastering process leads to diluted results. This indicates that the neural language model is returning to the archetypical conceptual space, in this case, the tree space, since we are originally trying to combine the thematic space of trees and the thematic space of slums through the action of braiding. Circumventing this can be addressed by prompt weighting, so the conceptual domain which is overridden is given more emphasis, as you can see in the second and third examples. I just want to end with a kind of, let's say, comment about the emergence of what has been called in its very early form as a semanticism, the adoption of neural language models as generative tools, and let's say a removal or a distancing from prior grammatical computational logics, and as has been identified by Stanislas Chailloux recently. Within architecture, this kind of integration has only been barely situated within architectural discourse. And yet, recent work already speaks of such a thing, like semantics as a kind of paradigm, as a kind of new paradigm. I think that our ability to capitalize on these new tools rests with our newly emerging sensibility to not only understand, but intervene in these type of methods, namely with the addition of domain-specific data that can circumvent the impermeability of the NLM training, which remains for the most part as a black box. While opening the box may be trickier, a conversation could begin which focuses on satellite aspects of design cognition brought forward by the opportunities and limitations of neural language models. Thank you.